Okay everybody, and welcome to this video. In this video we are going to go through some past paper questions in the topic of bearings and trigonometry, excluding the advanced trigonometry part of the syllabus. So before I get started though, I just want to emphasize how important it is to do your own work. If you are really serious about getting a good grade on the final exam, you really need to do your own work, and you cannot just copy from your classmates or from your teacher without thinking about it. If you copy from me in this video without trying them yourself, you're basically just wasting your time. You need to try them before you have a look at the solution, and then figure out where you went wrong and how you can do better next time. The same is true for tests. Okay, that said, let's get started. The first question is, as usual, we're going to start with the easy ones and we're going to work up to harder ones. The first question is, the scale drawing shows the positions of the town S and T. The scale is 1 centimeter, represents 15 kilometers. Measure the bearing of town T from town S. So we really don't need the scale in this case, but I guess they always give it. And in order to get the bearing of town T from town S, it means basically we want to calculate this angle. If I'm standing in town S and I want to know the bearing of town T, I want to know how many angles it is from the north. So in order to do that, first let's draw a line from town S. Oh, my mouse is a bit noisy. Straight to town T. And we have to be very precise here, because even a small difference might cause us to lose a point. Even making a mistake of 1 degree might cause us to lose a point. So there's a line from S to T, from the exact center of the dot down to the exact center of the dot T. And we're going to move this here. And we're going to have a look, make sure we got 0 degrees here. Make sure the exact center of this dot is on the exact center of the protractor. My protractor might be a little different from yours. And now down here we can read the angle. So in this case the angle is 135, 36, 37. Let me just zoom in to be a bit more precise. Excuse me. Oops. Be as precise as possible. So it's rather close to 137. These are pretty tricky, to be honest. It can be pretty hard to get a very accurate reading. Just do your best. Try to be as precise as possible. So down here we will write down the answer, 137 degrees. Let's make that blue. Okay, let's move on to the next question. It's just a 1-point question, so if you do get it wrong, that's okay. That's not the end of the world. Next question. Measure the bearing of town B from town A. So again, we have to draw a line. Let us draw a line from the exact center of A. Use your ruler for this, naturally. To the exact center of B. And let's measure the angle. But in this case, we're measuring the angle of town B from town A. So it means we're standing in town A and we want to measure the angle, the bearing of town B, the bearing from north will be this angle. There we go. Let's see, it is 68 degrees. 68 degrees. 68 degrees. Okay, so the next question is more of a math question. And for that, I'm gonna switch to pen mode. So I'm gonna pause the video and then I'll see you back in a moment. Okay, welcome back. The next part is about the medium questions. And we are talking about bearings again. In this question, we don't need a protractor. So let's read this question first and make a little sketch. The bearing of A from B is 137. So let's draw that. We start at B and we can draw the north line. It's just a sketch, so it doesn't have to be precise. This is B. And then 137 would be more than 90 degrees, but less than 180 degrees. So it would be somewhere like over here. And that would be A. That's the north, and that's the north direction too. So find the bearing of B from A. So we know this is 137, and we're standing in A now, and we want the bearing of B from A, which means we have to start at the north and go all the way around until we get that angle. That's the angle we're looking for. Yeah? So how can we get this angle? Well, it's easy. Let's just extend this line here. And we can easily see that this part is 137 and the remaining part is 180. So finally we have 137 plus 180 equals, let's put it in here, 137 plus 180 equals 317 degrees. The next question says, show that the value of x is 369 to one decimal place. 36.9 to one decimal place. And it's easy because we have two sides and one angle. So we know SOHCAHTOA, SOHCAHTOA helps us remember which function, sine, cosine, or tan, we use with which sides. The opposite side would be O, and this would be the hypotenuse. Remember, the hypotenuse is always to the opposite of the 90 degrees. And this is the angle we want. So which of these has an O and an H? It's obviously this one. So we know sine of x is equal to opposite over hypotenuse, right? And we also know that the angle is sine 36.9 is equal to 18 divided by 30. So let's check if this statement is correct. First thing I'm going to do is do 18 divided by 30, and I'm going to put that in the calculator. 18 divided by 30 is equal to 0.6. 0.6. And next I'm going to check sine 36.9. I'm going to put that in the calculator. Where's my sine functions? Here. Sine of, let me delete this first. Delete. Sine, open brackets, 36.9 equals 0.600, etc., etc. 0.600. So there's just a rounding error that proves that they are the same, which proves that this angle x must be 36.9. Easy peasy, right? Okay, the diagram shows a right angle triangle ABC, and we've got AC is 15 and BAC is 38, and we need to calculate BC. Another easy one. We go back to Sol, Ka, To, A. Let's see. This one is the opposite, and this is the opposite of the 90 degrees, so it must be the hypotenuse, and this one would be the adjacent. So we want to know, we have h, so it's going to be, so we can just see that it's either going to be the cosine or the hypotenuse, or the sine. It's going to be either the cosine or the sine that we need to use. But what do we want? Do we want the adjacent or do we want the opposite? We want the opposite, right? So it's the sine we're going to use. If we use the cosine, that would help us get the adjacent. But we don't want the adjacent, so we don't need this, and we definitely don't need that one. So we can do sine of 38 equals opposite, we don't know that, divided by hypotenuse, but we know the hypotenuse is 15. So let's rearrange this algebra. We're gonna go, let's write this O like this so that nobody thinks that's a 0. That's O for opposite, not 0. Okay, remember this rules of algebra? First of all, we do the opposite of something. Second of all, whatever we do on the left-hand side, we also do on the right-hand side, and vice versa. So I'm going to do it in a different color just to clarify. We have multiply the left-hand side, the right-hand side by 15. We're dividing O by 15, so we're going to do the opposite, which is multiplying. And we also have to do it on the left-hand side. If we do it on the left-hand side, we also have to do it on the right-hand side. So we just cross that out. First multiply by 15, then divide by 15. That's the same as doing absolutely nothing, right? Okay, so I'm going to rewrite this equation. I end up with sine of 15 times sine of 38 equals O for opposite. And now let's just flip the left-hand side and the right-hand side. We can do that too. So we get O is equal to 15 sine 38. All we got to do is put it in the calculator. So let's do that. Let's clear this. Go to sine of 38 equals multiplied by 15 equals. We just got to be careful for the brackets, for the order of operation. So let's be clear and put brackets over there. So we end up with 9.235. Normally we only need 3 significant places. So let's say 4, 9, and then we're gonna round it off to 3 significant places. That means we can cut those off. 9.23 centimeters. Okay, next question. The next question looks a bit more complicated than it actually is. So this is a good question that shows us don't panic when you see something. The diagram shows a field of P, Q, R, and S. It's a quadrilateral. It has 4 sides. We know one right angle over here, and we know 2 sides. There's a straight path from P to R. So there's a straight path from P to R. Calculate the length of this path. That's great because we have these two sides and we can use Pythagoras. We don't care about s. S is boring for us. It doesn't help us in any way and we don't need it. So why did they add it to the question? Just to see if we would get confused or not. Just to make the question a bit more complicated. But sometimes they just do that to see if we panic or not, and if we keep calm and we don't panic, we get the question right, no problem. Oh yes, so what was Pythagoras? Pythagoras is like this: a squared plus b squared equals c squared, where c is the hypotenuse. I always forget. Hypotenuse, like that, I believe. Okay, it doesn't matter how you spell it, as long as you can do the math right. The hypotenuse is always the opposite of the 90 degrees. So in this case, P and R is a hypotenuse. That's the one we want. That's great. The other two, it doesn't matter which one you pick for A and which one we pick for B. So let's just do it. 97 squared plus 98 squared equals c squared. That means we'll end up with c squared equals, let's just put it in the calculator, 62. Where's the squared? Where's the squared? Okay, you know what? I'm just gonna do it. Yeah, let's do it like this. 62 times to the power of 2 equals 4489. 4489 plus 98 to the power 2. 98. Oh, it's here. Okay, to the power 2 equals 9604. So then I'm just going to add them together. 14093. And then C. This is algebra 2. Huh? I'm squaring on this side. And what's the opposite of squaring? Square rooting is the opposite of squaring. So let's do it like this. And what I do to the left-hand side, I also have to do to the right-hand side. So if I square root the left-hand side, I also have to square root the right-hand side. 4489 plus 9604 equals. So we go here, square root equals 118.7. 118.714, but we only need three significant places, so we can cut that off. But then it becomes 119. 119. Okay, let's move on to the next question. They're getting slowly harder, but they're still medium questions, so we're still on track for a C or a D. But don't forget, if you don't get you don't need to get all of these right to get a C or a D. In fact, you might get partial credit on the hard questions, and then you really don't need all of these. But you need to have a good, get at least partial credit on these C and D questions. Okay, calculate the value of x. This is a bit more tricky because we need to do it in multiple steps, but as you can see, we get 5 points for it. Excuse my son and his friend playing computer games. I hope they're not too disturbing. Okay, we've got to find x. How do we find x? The first step to find x is we've got to get either this distance or this distance. And if we do that, we can use the sine rule or the cosine rule to get x, but we don't have this distance or this distance. But can we use the other triangle to determine this one or this one? Right, we can use the other triangle to determine this height. So this is a bit more tricky because we need 2 steps to get to the answer, but on the other hand, we have more opportunities to get partial credit. So to get just 2 or 3 points, I'm pretty sure we're going to get some points for getting the height. So here we have Pythagoras again. A squared plus b squared equals c squared. And remember, c squared is the hypotenuse. Hypotenuse. Yes? So that's this c. And that's this. Excuse me. That's the opposite of the 90 degrees angle. So the 90 degrees angle is over here. So the hypotenuse is 13.6. A and B, it doesn't matter which one we choose. So let's just fill it out. 7.4 squared plus B, the other one, we don't know it, B squared, is equal to C squared. 13.6 squared. Now we got some algebra again. Instead of doing algebra, let's work out these squared values first. So we're going to start with 7.4 squared, 54.76 plus b squared equals 13.6 squared. 184.96. So now we're back at algebra. Algebra is very important. We want b by itself. As a first step, we want to put b by itself. We'll worry about the squared later. So we are adding 54.76 on this side. So what's the opposite of adding? Is subtracting. Right? So we're gonna subtract 54.76. So I'm gonna write it out very many clear and precise steps. It's a bit boring, right? But that's the curse of being a teacher. I have to do all this boring stuff. But if you know this well enough already, just skip ahead. Do it yourself. You don't have to write every single step in as much detail as I do, if you feel confident. But if you don't feel confident, it's useful to write it down in just as many steps as I do, until you start feeling more confident. Okay, so we're adding, let's do a different color. We're adding a certain amount and then subtracting the exact same amount, and it's just like doing nothing, right? And here we have to, if we subtract from one side, we have to subtract it on the other side too. So we have this minus this. We get 184.96 minus 54.76 equals 130.2. So we end up with b squared is 130.2. And then we're gonna square root both sides, just like last time. What's the opposite of squaring? Square rooting is the opposite. If I do something to the left hand side, do I also have to do it to the right hand side? Yes. So square root of b squared equals square root of 130.2, which means b is equal to the square root of 130.2, which means it's equal to oh, I didn't need to delete it. Anyway, 130.2 equals 11.4. 105. Now that we know this distance and we know this angle, we realize that we can use one of these SOHCAHTOA things for figuring out the remaining distance, right? So which one do we need to use? Let's write it out. SOHCAHTOA. This is the opposite of 90 degrees, so it's H. This is 41 degrees, and the opposite of 41 degrees is O, which one we know. So let's see, which of these uses the h? The sine and the cosine use the h, so we know the tangent is not going to be that useful for us. The other one, which uses the o, it's the sine. So that means the cosine is not that useful for us. So let's see. We're going to write it out. Sine of 41 degrees is equal to h opposite 11.4105 divided by hx. Now we're going to use algebra again. We're dividing by x. Let's see. When your unknown is at the bottom, the easiest thing to do is to just flip it upside down and we'll end up on the top, right? But if I flip the right hand side upside down, then I also have to flip the left hand side upside down. So I end up with x divided by 11.4105 is equal to 1 divided by sine of 41. And now I want to get rid of this 11.4105. Right now I'm dividing. What's the opposite of dividing? Multiplying. Let me just draw a little line here to clarify that that belongs to the other side. So the opposite of dividing is multiplying. So I'm going to do x divided by 11.4105 multiplied by 11.4105 is equal to 11. I can't write it, 0.05 divided by sine of 41. And that cancels with that. So I end up with x is equal to 11.4105 divided by sine of 41. So let's calculate it. 11.4105, we already have it in the calculator, so we can keep it like that. Divided by, now I'm going to open the brackets just to be on the safe side. When in doubt, use brackets. So it's equal to, x is equal to 17.4. Because it's a final answer, we can round off to pretty significant places. 17.4 centimeters. Okay, so this is a pretty tricky question, and if you got it right, you're really on the right track and you will soon be ready for the exam. Keep working at this level. If you tried it and you got it wrong, that's okay. It's pretty tricky, but hopefully you learned something through trying. But if you just copied from somebody, you're just wasting your time, really. So better try it yourself and make sure you're able to solve problems like this, or at least have a good shot at solving problems like this and get partial credit before the exam. Okay. The diagram shows a trapezium. The trapezium has one line of symmetry. So the line of symmetry, we need to, this is why I think it's tricky. We need to see where the line of symmetry is, and it's clear once you get some experience with it that it's running down the middle like this. And that implies that this angle is equal to this angle. And once you realize that, you will realize that this distance is equal to this distance. And then in addition to that, we also need to know how to calculate this distance using a trigonometric function. And in addition to that, we also need to know the area of a trapezium. But on the other hand, if you don't know the formula for the area of a trapezium, you can always split it up into one rectangle like this, A1, and two triangles, A2 and A2. Since it's symmetrical, we see that A2, this triangle has the same area as this triangle. Okay, so let's get started. First of all, we're going to calculate this distance. We're going to use one of those weird SOHCAHTOA things again. But which one? Let's write it down. SOHCAHTOA. So which one is the opposite? This one is obviously the opposite. Which one is the hypotenuse? The one on the opposite side of this right angled triangle is the hypotenuse. And which one is the adjacent? It's the remaining one, right? SOHCAHTOA. Which one do we want? Which ones do we know? We know this one. No problem. So it's one of these. It's not going to be cosine. It's going to be either tan or sine. What do we want? We want the A. We don't want the H. We're not really that interested in the H, because the H is not going to help us calculate the area of the trapezium. So we don't worry about the sine. Tangent. Tan of 62 equals opposite 18.2 over adjacent, which is what we want. We want the adjacent, so you're going to have to flip it upside down to make it, put it in the numerator, right? A divided by 18.2. Remember, if we flip the right hand side to the numerator, we also have to flip the left hand side to the numerator. So we're going to do 1 divided by tan 62. Remember, if it's not clear, this is the same as this divided by 1. So that's how it how the 1 ended up on top. I hope it was clear in the previous question. Anyway, if not, let me know in the comments. Okay, now we're going to get rid of this 18.2. And right now we're dividing by 18.2, but we want to get rid of it, so we do the opposite. What's the opposite of dividing? Multiplying is the opposite of dividing. So let's try it out. A divided by 18.2 multiplied by 18.2 equals 18.2 divided by tan of 62. This cancels with this. First dividing and then multiplying by the exact same number means I did nothing. And the rest I can put in the calculator. Let's do it. 18.2 divided by, open brackets, 10/62, close brackets, equals 9.67711. We're not ready yet with our final answer, so I'm not going to 9.67711. So I'm not going to round yet. 656. I'm going to leave it like that. And I'm pretty sure we got already partial credit at least. Let's see if we can get the remaining points. So it's the area of a trapezium. What's the area of a trapezium? If you remember, it was A equals half of base plus top multiplied by H. H is 18.2. Base is this length plus this length plus this length. Top is this length. So we got a is equal to half plus the base, which is a, 9.67711,656, plus this length 15.4, plus, you know what, to save space I'm gonna do like multiply by 2 over there, plus, and I'm gonna, for the examiner's sake, I'm gonna draw a little line down there. Okay, a is that plus that times 2, 1 for that one, 1 for that one, 1 for the middle, plus the top is 15.4 again, plus the multiplied by the height is 18.2. So let's see, we've got this multiplied by 2 plus 15.4 plus 15.4 is equal to that, multiplied by 18.2, and all of that divided by 2. It would be such a pity if we forgot to divide by 2 at the end. Is 456 centimeters squared. So we ended up with like 456. Okay, next question is this one. This should not say easy, obviously, this should say difficult. And the very first one you will recognize. Those of you who did your homework will immediately recognize that this is the bonus question from the other paper I gave you. And those of you, so you should have had an easy time with them, in spite of it being difficult. Those of you who did not take your homework seriously must have had a hard time with this. Anyway, let's see. The diagram shows a rectangle with length 11 and 4. OQ is the diagonal. OPX is a sector of a circle of center O, the percentage of the rectangle that is shaded. So we want to calculate the area of the rectangle. That'll be easy, right? It's just 11 times 4. 11 times 4 equals 44 centimeters square. And then we want to calculate also this angle, because we're going to use this angle to calculate this area. So the area of the semicircle, semi-C, is equal to the beta divided by 360 multiplied by pi r squared, and in this case r is equal to 4. Theta divided by 360 multiplied by pi 4 squared, right? However, we don't know this beta, but can we calculate it? Yes, because this is a triangle. It's a right angle triangle, and we're gonna use SOHCAHTOA to calculate theta. So let's do it again. SOHCAHTOA. We know the opposite, right? 11 is the opposite. We know this one. So which one does not include the opposite? It's the ka. It's not going to be useful. What about this one? Is it the hypotenuse or the adjacent? Well, this one is a hypotenuse, right? Because that's the opposite of the 90 degrees angle. So it must be the adjacent. So we need this one, and that's not going to help us. So we're going to write it like this. Tan of beta is equal to opposite 11 divided by adjacent is 4. But we don't, now comes a weird thing in algebra. We've got to do the opposite of tan, and the opposite of tan is the inverse tan function. And whatever we do to the left hand side, we also do to the right hand side. So we're going to do it like this: tan inverse of tan of theta equals tan inverse of all of this. And then this tan inverse cancels with this tan. Great, right? Okay, let's calculate it. So we end up with, where am I going to write it? Theta is equal to tan negative 1. You should have a button on your own calculator, but I'm going to do it my way. 11 divided by 4. 70 point. Remember, we're not done yet, so we can't really round too early. 0, 1, 6, 8, 9, 3. That should be enough. Now we're gonna fill that in over there. So that's equal to that divided by 360 multiplied by pi multiplied by 4 squared. So the area of the semicircle is 9.776203. Okay, now we're going to calculate the percentage of the shaded area. So the shaded area is the rectangle minus the semicircle. That's the area of the shaded area part, divided by the whole part, which is 44. And all of that multiplied by 100 equals 44 minus 9.776203 equals divided by 44 multiplied by 100, 77.8. Ta-da! Okay, next question. Okay, to find the diagonal of a cuboid is just like with Pythagoras, but we've got simply got to find the square root of 24 squared plus 12 squared plus 8 squared. And let's just put it in the calculator. And then we've got to find the square root of that. And that's equal to 28. That's an easy one, right? Okay, next. Sketch the graph of y equals sine x plus y equals sine x. So remember the key points of this was at 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360. Oh, by the way, in case you're curious, yeah, ignore me. So this would be exactly halfway between 0 and 360. This would be halfway between 0 and 180. while this would be halfway the remaining part. If you don't remember what the key points were of this graph, that's okay. We can just go and we can say sine of 0 equals, have a look, 0 sine, and then go back to, excuse me, sine of 90 degrees is 1. Sine of 180 is 0. Sine of 270 -1. Sine of 360 0. Okay, so at 90 degrees it's gonna be 1. At 0 degrees it's gonna be 0. At 180 degrees it's gonna be 0. At 270 it's gonna be -1. And at 360 it's gonna be 0. So hopefully that's enough to remind you that it's a wave like this. Next we have a pretty tricky question, and let's see how to solve it. It's algebra. We've got 3 sine x plus 1 equals 0. So first of all, we're gonna say, what are we gonna do to get rid of this plus 1? Well, we're adding something on the left hand side, so we gotta subtract the same number to remove it. But what we do on the left hand side, we also have to do to the right hand side. So let's do it. 3 sine x plus 1 minus 1 equals 0 minus 1. And we end up with 3 sine x equals -1. Okay, next we're multiplying by 3, but we want to get rid of that to end up with something simpler on the left hand side. So we're gonna divide by 3. Okay, let's do it. 3 sine x divided by 3 is equal to -1 divided by 3. And then that cancels. So we end up with sine of x is equal to -1 divided by 3. So what about this? Well, as I told you, the opposite of sine is the inverse sine. And we remove that cancels, and we end up with x is equal to sine inverse of 1 divided by 3. Let's put that in the calculator. So here I am again. In the original recording, I kind of made a mess of explaining this part. So after I finished the recording, I decided to come back and then I would edit the video later, and I'm going to explain this part a bit better. So let's see. Here we have sine x is -1/3. To get x, we just use x equals sine inverse of -1/3. Let's put in the calculator and see what we get. We've got sine -1 of, open brackets, -1 divided by 3 equals -19.47. You probably get something else on your calculator. I don't know what you get on your calculator, but I get -19.47, which is kind of a weird result. And we're looking for a solution to the equation from 0 to 360. So it's not even in the range of the required solutions. Not to mention that there's 2 possible solutions judging by this mark scheme. So what am I supposed to do? Well, let's have a look. Let's have a look at how the sine function looks like. As you can see, the solution we found was over here. When x is negative 19, something like over here, sine of x is negative 1/3. Right? Makes sense, right? But where else is sine of x negative 1/3? So it's somewhere over here, really. Sine of x is also negative 1/3 over here, and sine of x is also negative 1/3 over here, if we draw this line. And what we're looking for is this value and this value. And we know this distance, which is 19.47. This distance is also 19.47, and this distance is also 19.47. So in this case, we can find this point, x, by adding 180. 180 plus 19.47 equals, let's just do this thing, multiplied by negative 1 to make it positive, and add 180. And we end up with 199.47. Or 199.5. That's one possible solution. The other one is 360 minus 19.47. So let's subtract 180 from that again to end up with 19.47, and then go 360 minus that equals 340.5. Pretty complicated stuff, right? It's pretty hard to understand if you are not familiar with this, but don't worry if you don't understand. We're going to practice more. And remember, it is one of those questions which eventually might let you get an A star. So just focus on getting if you find it really hard, focus on getting partial credit on questions like these, and then you'll still be on track to get an A or a B. Okay, let's move on to the final question. This is a very, very difficult question for beginners. But hopefully, once you get more practice, you'll be good at this type of question too. So the diagram shows an open rectangular box. All these distances are labeled here. And there's a straight stick over there. Calculate the angle between the stick and the base of the box. So what are we actually looking for over here? Let's draw a line from here to here. Oops. So that we can better visualize what we're looking for. We're looking for this angle. And this angle, we can find it using this distance and this distance. So this is going to be angle A and this is going to be L. But we don't know L. But can we find L? Yeah, this is a right angle. So we can find L using Pythagoras. Let's do it. L squared equals 9 squared plus 18.6 squared. So L is equal to the square root of 9 squared plus 18.6 squared. Let's put it in. 9 squared plus 18.6 squared equals, and then the square root. It's equal to 20.66 centimeters. Now we've got to find this angle. This is a right angle too. Excuse me. It's a right angle. And we know this length, and we know this length, and we want this angle. So let's do the SOHCAHTOA thing. SOHCAHTOA. Let's see. We have the opposite, right? We know the opposite. So we don't need this. And we know, do we know the hypotenuse? Hypotenuse? That's this? No, we don't know. So we use tangent. Tangent of the angle is equal to opposite over adjacent, which is L. Let's put some more. So we got A is equal to the tan inverse of 0.701. 737 is equal to 35.1 degrees. Now AM is equal to 30 centimeters. A is over here and M is over here, so we know the distance all the way to the end of the stick is 30 centimeters. Show that GM is equal to 4.8, correct to 1 decimal place. Okay, not so hard. First of all, we need to calculate this distance from A to G. Let me just erase this a little bit so we can see. And we know this distance and this distance, so that should be easy. So let's see. AG is equal to, AG squared is equal to L, 20.66301 squared plus 14.5 squared. So that means AG squared equals oops. $637.20998, which means AG equals the square root of that answer, 25.243. GM equals GM is equal to AG plus G. GM plus AG equals AM. So this small distance plus this distance is equal to the total length. So AG plus GM equals AM. We know that AM is 30, the AG is 25.243, plus GM equals 30. So therefore, GM equals 30 minus 25.243 equals 4.8 approximately centimeters. Correct to 1 decimal place. Okay, that's it. Thanks for watching. See you next time.